today we're going to start discussing about your 40th class of the session, and which is your in 40th class we have to deal with your equilibrium of a particle, where we had done the conservation of momentum as well in the last classes. So today we'll just start discussing about equilibrium of a particle here. In equilibrium of particle, before that we had started with unit 5, which is laws of motion, and this is your 8th topic that we are dealing in the laws of motion. So before starting with the same, it's a huge request to all the viewers to please go ahead with like, share and subscribe, and go with the playlist. You will find out each and every video there. Today we'll start discussing about equilibrium of particles. Equilibriums of particle here. In this, where an equilibrium of particle is a mechanic that refers to a situation when the net external force on a particle is zero. So according to that, I just write it in for the equilibrium of particle that you can be measured here. Equilibrium of particle. In mechanics refer to the situation when the net external force particle is zero. According to the first law, this means that the particle is either all set or any uniform motion. If two forces F1 and F2 act as a particle, equilibrium requires F1 equals to minus F2. On the same way, that is the two forces on a particle that must be equal and opposite, and equilibrium under the three concurrent force F1, F2 and F3 that require the vector sum of the three forces is zero. So for that, so here F1 and F1, if it is in same direction, and that is equilibrium under the concurrent forces, it will give you, if this is F1, this is F2, so this is F1 as F2, so F1, F2, this is F3. So equilibrium under the concurrent forces. Now for that equation, here, in order the resultant of any two forces, says F1 and F2, that are obtained by the parallelogram law of forces, that must be equal and opposite to the third force F3, as seen, you can see here. The three forces in equilibrium that can be represented by the side of triangle with a vector arrow that take in the same sense. The result can be generalized to any number of forces and particles. A particle is in equilibrium under the action of forces F1, F2 till Fn if they can be represented by the side of the closed and sided polygon with arrows directed in the same sense. and for that it will be that we have reactions here, f1x, f2x and f3x. Goes to 0. The second is f1y, 0, and for f1z, goes to 0, where f1x, 1y and 1z are the components of f1 along with x, y and z directions respectively. Now we go for another question that we have as follows. The question is, a mass of 6 kg is suspended by a rope of length 2 meters from the ceiling. A force of 50 Newton in the horizontal direction is applied at the mid point P of the rope as shown. What is the angle of the rope that makes with the vertical in equilibrium? You have to take G equals to 10 meters second inverse square. Neglect the mass of the rope here. So that is the question. Let's go for it. So for that we'll go for it. A man of 6 kg is suspended by a rope of length 2 meters from the ceiling. A force of 50 Newton in the horizontal direction is applied at the midpoint P of the rope. What is the angle the rope makes with the vertical in equilibrium? You have to take G equals to 10 meters second inverse square. Neglect the mass of the rope. So the figure we have. So this is the question, that is your homework, and I will discuss this question in the next coming class. So here, stay tuned with us and please like, share and subscribe so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.